Patrícia, puseram você aqui, eu acho. Não, Neto? Ô Luiz, fala com ele lá, ó. Bom dia a todos. Nós vamos... O evento... Na história aqui do evento, depois a Patrícia vai falar, Patrícia do IAAT, tudo começou com nós organizando aqui a vinda do professor Alan Scher, do doutor Alan Scher, e aí nós resolvemos fazer o IAAT é um instituto de estudos avançados na área transdisciplinar, né? Então, nós resolvemos aí organizar um evento que era transdisciplinar, que eu acho que, às vezes, o pessoal olha, mas o que tem a ver uma coisa com outra, né? Mudança climática e doenças infecciosas e resposta imune, mas realmente tem tudo a ver, né? Então, mudanças climáticas afetando aí que nós estamos vivendo, afetando aí todo o ecossistema global, né? E aí a emergência e reemergência de doenças infecciosas, nós estamos vendo aí o tempo todo, e a resposta imune, né? Como nós vamos nos defender aí desses agentes infecciosos. Então, nós organizamos essa manhã, nós vamos falar principalmente de doenças, de mudanças climáticas relacionadas com algumas das palestras relacionadas com doenças infecciosas. E, à tarde, nós vamos ter uma sessão de vacinas. Amanhã também nós vamos ter outra sessão sobre patógenos emergentes e reemergentes, e também uma sessão de doença, né? Como que papel do sistema imune na patogênese dessas doenças. Então, acho que ficou uma coisa bem interessante. Tivemos aí o prazer de ter um grupo de cientistas de primeira linha aceitando participar do evento, e estamos aí entusiasmados para os próximos 2 dias. Só depois nós recolocamos aqui o programa do evento, que houveram umas mudanças, sabe? E vocês vão ver aí. Mas em base, o programa está quase que fiel ao que está proposto, mas é bom vocês darem uma olhada aí, que houve pequenas alterações, mas praticamente está muito próximo do que estava proposto originalmente. Teve um ou outro que cancelaram, nós mudamos o nome, ou teve uma pessoa que entrou no lugar de outra, o tema, em geral, se manteve o mesmo. Então, para não demorar muito, eu vou agradecer aí a todos pela participação, os cientistas e gestores da ciência que aceitaram vir, e muitos vieram de longe, né? Eu acho que isso aqui é ótimo para a universidade, é um ambiente muito rico. Nós temos aí uma parte grande da audiência, nós fizemos uma disciplina no departamento de bioquímica, então nós vamos ter uma participação grande de estudantes, né? Então, é isso que é a universidade. Então, é isso. Agradeço a todos aí. Vamos passar. Quer falar, Luiz? Eu acho que você fala, depois a gente passa para a Patrícia, depois para a Cris.
Bom dia a todos e todas, né? E queria agradecer a presença de todos aqui, né? De todos os componentes dessa mesa, né? A doutora Sandra Goulart, né? Tá. O doutor Fernando, tá? O Ricardo, né? O Ricardo Gazzinelli também, que ele foi o mentor disso tudo aqui. Eu só ajudei com poucas coisas, né? Então, foi um grande trabalho, né? Um evento que emendou com outros eventos, que começou já há 2 dias. E agradecer também, o Tulio chamando aqui, a presença também do Ministério da Saúde, né? Tem a Secretaria de Saúde Indígena, que é a doutora... espera aí só um pouquinho. Pronto. Né? A doutora... está aqui, porque muda muito na ordem aqui, né? Então, a gente tem aqui a Adriana Lucena, do CESAI, tá? Que nos acompanha desde da COP29, lá no Azerbaijão, né? Participou junto com a gente o grupo do CLIMADE, né? Que o Tulio de Oliveira, o primeiro palestrante, vai falar um pouco sobre o CLIMADE, tá? O Dr. Fabiano Pimenta, que também é do Ministério, né? Da Secretaria de Vigilância em Saúde e Ambiente, tá? Que vai participar também desse evento, e alguns membros da OPAS que estão chegando aí, tá? São 3 membros da OPAS Brasil, né? E eu acho que esse evento, esse workshop, vai dar para a gente discutir muito sobre como essas mudanças no clima estão amplificando doenças, né? Levando à emergência e reemergência de patógenos, que isso é tão importante na minha área, né, que estuda evolução, que estuda essas emergências de patógenos, como o desenvolvimento de vacinas. Nós sabemos que tudo, o clima, mudança no clima, altera tudo isso, né? Então, no mais é isso, eu não vou me alongar aqui, não. Tá? Obrigado.
Bom dia a todos e todas. Meu nome é Patrícia Kawark Leite, eu sou diretora do Instituto de Estudos Avançados Transdisciplinares da UFMG. E estou aqui a convite do professor Ricardo Gazzinelli para celebrar essa parceria do IAT com o Centro de Vacinas da UFMG, com o Instituto de Ciências Biológicas, principalmente no acolhimento da vinda do professor Alan Scher como um dos nossos catedráticos visitantes. Eu vou falar um pouquinho para vocês do IAT, não sei se todos conhecem, o IAT fez, o ano passado, 25 anos. Ele foi criado justamente para promover a pesquisa de ponta e transdisciplinar em questões e problemas que afetam a sociedade, mas que exigem soluções que não dependem de uma única disciplina, de um único campo de saber. Então, o IAT ele foi criado para promover esse diálogo entre conhecimentos, entre áreas da ciência, no caso aqui, especificamente, da mudança climática e dos surgimentos das doenças. O IAT ele funciona através, então, ele foi criado para atrair pesquisadores externos à nossa instituição, externos ao UFMG, para interagir com os grupos locais. O IAT, então, é um instituto que pertence a toda a universidade. Ele não tem um corpo de pesquisadores fixos, os pesquisadores que estão no IAT são transitórios, e ele funciona através de diversos programas. Então, tem um dos programas, é o programa de residência interna, em que nós acolhemos professores e pesquisadores da nossa própria instituição, mas os programas que justificam até a existência do Instituto são os programas de visitas internacionais e de cátedras de curta duração, e agora estamos implementando os programas de cátedras de longa duração a partir de temas e de grupos de pesquisa transdisciplinares que estão já consolidados na universidade. O ano passado, então, criamos 2 novas cátedras de longa duração, a cátedra Magda Soares, ligada à educação básica, a cátedra Darcy Ribeiro, ligada, então, ao problema da soberania nacional, da educação e da política, e estamos em vias agora de consolidação de mais 2 novas cátedras de longa duração, uma ligada à desinformação e o problema da inteligência artificial, e a outra cátedra ligada a saberes tradicionais. Mas o professor Alancher vem dentro de um programa muito tradicional e consolidado no Instituto, em parceria com a nossa Fundação de Apoio à Pesquisa, que é a Fundep. Esse programa é o programa mais consolidado de atrair para o IAT, e atrair para o IAT, e atrair para o UFMG pesquisadores de grande nome, como é o professor Alancher. Então, eu agradeço muito ao Ricardo por essa parceria que tornou possível aí a inserção do IAT na promoção de um evento tão importante como esse. Agradeço também a presença de vocês e passo a palavra, então, ao professor Ricardo.
Bom dia a todas as pessoas. Meu nome é Cristiana Brito, eu sou diretora da Fiocruz-Minas. Gostaria, inicialmente, de agradecer o comitê de organização desse encontro pela grande oportunidade de nos colocar juntos para discutir um tema de extrema relevância atual. É uma grande honra estar aqui hoje, nesse simpósio, que está sendo organizado pelo CT-Vacina e pelo consórcio CLIMADE. A Fiocruz-Minas, estou aqui representando essa importante instituição e gostaria, então, de estender calorosas boas-vindas para todos os participantes, pesquisadores, estudantes e todos os profissionais, não só do Brasil, mas de todo o mundo, que juntos vamos refletir sobre esse tema urgente e complexo. Então, as mudanças climáticas, elas não são mais uma ameaça distante e abstrata, mas o seu impacto já é visível na dinâmica da emergência de doenças infecciosas, na mudança dos padrões de transmissão e nas vulnerabilidades que as mudanças climáticas têm criado nas populações e nos ecossistemas. Os seus efeitos têm gerado impactos importantes na saúde mundial, na segurança alimentar, na migração e, é claro, na separação. Desculpa, eu escrevi minha coisa toda em inglês e agora eu estou fazendo um shift de tradução simultânea. Nessa disseminação e evolução das doenças infecciosas, de forma muito particular aquelas doenças que são transmitidas por vetores. Então, tratar desse desafio demanda não somente uma excelência científica, mas também estratégias coordenadas que vão além das disciplinas e das fronteiras. Esse simpósio ele exemplifica o tipo de colaboração, de esforço colaborativo e integrativo que é essencial para que a ciência consiga direcionar os seus esforços a serviço da saúde global. Então, o diálogo entre imunologistas, epidemiologistas, pesquisadores da genômica e cientistas de dados deve refletir esse compartilhamento do conhecimento. Todos eles em busca de respostas para a gente construir juntos essas respostas. A Fiocruz, como instituição pública, fazendo esse ano 125 anos, tem um lugar estratégico nesse contexto. Nós estamos envolvidos na produção científica, de conhecimento científico de alta qualidade, soluções inovativas e o desenvolvimento de políticas públicas baseadas em evidência. Na Fiocruz-Minas, nós somos particularmente envolvidos na pesquisa para responder às ameaças de saúde que estão emergindo rapidamente nesse mundo em transformação. Essas ameaças elas estão profundamente interconectadas com o ambiente, com a sociedade, os aspectos sociais e as transformações tecnológicas. Eu gostaria de reconhecer a liderança do professor Ricardo Gazzinelli e do time do CT-Vacina, assim como a coordenação do consórcio CLIMADE, do Dr. Luiz Carlos Alcântara e Dr. Tulio de Oliveira. A sua visão e dedicação têm tornado possível esse encontro. Gostaria também de desejar a todos os participantes que, nesses próximos 2 dias, a gente tenha uma troca, uma inspiração e o início de colaborações que vão não apenas compartilhar o conhecimento, mas criar essas conexões para contribuir nesse delineamento de respostas efetivas para os desafios de saúde que estão sendo impostas pela mudança climática. Então, eu desejo a todos um simpósio muito produtivo e inspirador, que a gente saia desse simpósio com novas ideias, novas parcerias e uma motivação renovada frente a esses desafios. Muito obrigada e um ótimo evento a todos.
Tudo bem, bom dia. Eu sou Fernando Reis, pró-reitor de pesquisa. Estou nesse ato representando a reitora, a professora Sandra Almeida. E, portanto, me cabe, em primeiro lugar, dar as boas-vindas a todos que nos assistem, nos visitam, que estão presentes nesse evento, em nome da reitoria da UFMG. É uma alegria sempre hospedar eventos científicos de alto nível, especialmente aqueles que têm a liderança de grupos fortes e importantes da nossa universidade, congregando pesquisadores da mesma área de todo o Brasil e de vários outros países e instituições internacionais. A UFMG tem um programa muito exitoso que chama Centros Institucionais de Ciência, Tecnologia e Inovação. E aqui estão representados, em primeiro lugar, o Centro Institucional de Vacinas, que é um grupo de pesquisa com um respaldo institucional, com uma personalidade institucional que transcende as disciplinas, transcende departamentos e institutos acadêmicos e que tem um vínculo formal com a reitoria diretamente, e esse modelo de gestão ele tem sido um grande avanço para pesquisas inovadoras, disruptivas e de impacto tecnológico, como esse Centro de Tecnologia em Vacinas realiza. Da mesma forma, nesse simpósio, como uma prova da interdisciplinariedade do evento, além da participação do Instituto de Estudos Avançados Transdisciplinares, nós temos também a participação de um outro CT, um outro Centro de Tecnologia e Inovação Institucional, que é o de Modelagem Ambiental, que está aqui representado pela professora Sônia, terá uma palestra também de um outro membro do CT mais tarde. Além da forte interação com o Centro de Tecnologia em Inteligência Artificial, em Saúde. Então, esse modelo tem sido de grande êxito e aqui é a prova disso. Então, eu quero agradecer a todos os envolvidos por a organização desse evento, que muito nos orgulha, dar as boas-vindas a todos que nos visitam. To the invited speakers, a warm welcome. Be with us these 2 days. I hope you enjoy the campus. E obrigado a todos, e acho que está encerrada essa parte da sessão. Obrigado.
Só queria um último aviso. We would like that most of the talks will be in English. We have quite some people from outside. So ideally, if you can talk in English, would be better, but that's still some that want to speak in Portuguese, okay, but I'll ask most of you to speak in English. And now we go to the introduction of the first speaker.
Bem, agora eu vou fazer a introdução do Tulio, né? Ele já está ali online, o Tulio de Oliveira. Tá. Tulio is from the University of KwaZulu-Natal in South Africa. He has a postdoctorate at the Oxford University, and actually he is a professor at the University of Stellenbosch in South Africa, and director of the Center for Epidemic Response and Innovation, it's the CERI, in Stellenbosch University, and also the director of the KwaZulu-Natal Research and Innovation and Sequence Platform, is CRISP, in the University of KwaZulu-Natal. Tulio, in addition, Tulio is the PI responsible for research and surveillance of SARS-CoV-2 in South Africa, detecting the variants Beta and Omicron during the COVID pandemic for the first time, and also responsible for the great job entitled Libya Outbreak. I think many people have seen about this work from Tulio that was in Nature also. He played in this Libya outbreak a crucial role in the investigation of the HIV outbreak in Libya, HIV and HCV, which culminated in the sentence of 6 health workers to death in 2009. Dr. Oliveira and his team's research demonstrated that HIV transmission in Libya and the hospital in Benghazi in Libya occurred due to the failure in infection control measures at the hospital, and not by deliberation transmission by the accused. This was for me, is the best work for Tulio, because he saved the life for six health workers in Libya. They was from Bulgaria, and he was laureated, including in France, for Sarkozy, during the Sarkozy presidency in France. And he's a good friend, and also Tulio started the consortium CLIMADE and invited me to be with him in this consortium. And it's a pleasure to have Tulio here. We wanted to have him in presence, but it was impossible. But next time he will be here in Brazil. Thank you.
Bom dia a todos, and good morning. Desculpa que eu não estou aí em Minas, mas eu estou indo ao Brasil com o Luiz para uma reunião também em programa no final de julho, em Brasília, para tentar avançar o programa do CLIMADE e linkar a COP30. So I just thought that was polite that I start in Portuguese. I got the instructions to give the presentation in English. So it's a great pleasure to be working with Luiz for over 2 decades, and also have advanced this program together. So what I have prepared for you, it's a presentation around 20 minutes. I would just ask the people to allow me to share my screen on the Zoom, so I can do that. At the moment I cannot. That just talk about the whole process that we did, going from setting up a very advanced genomic surveillance program for COVID in South Africa, and that as part of that, engage with multiple funders to setting up mRNA hub, the WHO mRNA hub, which then is now beginning to produce vaccines, the first ever vaccines end-to-end in Africa. And that's great because Fiocruz is part of this mRNA hub program. And then I will mention some of the big activities that we are doing now on CLIMADE, that advance in genomic surveillance, but taking them to vaccines. Then again, Luiz, por favor, se tu pedir para as pessoas deixarem eu botar minha apresentação. No momento eu não tenho acesso a isso no Zoom, eles têm que me dar permissão. So until they solve that, I can just give them the story. So we got some very large investment in South Africa for genomic surveillance and vaccine design. And then what we decided is then to pivot to what would be the most important challenge that we see happening. That is the disease amplified by climate change. And then what we did that is to set up a global consortium, but a global consortium with a change that now it is led by the Global South. So this program is led by our team in South Africa and by Luiz's team at Fiocruz in Minas Gerais. And that's quite unusual when you can put a whole global program led by the Global South. And what I'm going to share with you, it is the results that already impact on science, but also development of the biological countermeasures. So just quick, in South Africa, that's the map of South Africa. In the beginning of the pandemic, we set up a very efficient network, fully funded by our government, the South Africa Medical Research Council and the Department of Science Innovation. We set up 9 genomics facilities around the country, all of them next to a green box that is a big government laboratory, which would be the same as the LaScience in Brazil. Once we detect the first variant, the beta variant, we got a big injection of funding of our government. And then we create a very large network of over 500 scientists going from genomics, virology, immunology, clinical trials, and epidemiological modeling. I coordinate this network, and that led to the discovery of Omicron. And then as the pandemic recedes, we put a competition, a global competition that won the World Health Organization mRNA Hub, that started bringing this technology to South Africa, but then South Africa served as a training program to the world. Large program, close to $200 million entered in that program. And then in South Africa, we also did some very large investments in facilities. Our university, with our government, put up this state-of-the-art biomedical research institute, which is really geared to host 1,000 scientists. Just to get an idea of the development of that, on the top floor on the left, we have 28 BSL-3 labs, that's biosecurity level 3 labs, some of the biggest compound in the world. In the bottom, we have the largest biorepository in the Southern Hemisphere, and then we equipped also with the largest genomic surveillance in Africa. But we thought that we should not only do that for South Africa, so we engaged with the Africa CDC and the WHO Afro to create a program that involves all the African countries, what you call the pathogen genomic program, the African one, which we are one of 3 of the specialized genomics facilities. This means with a mandate to produce data for the whole continent. And that's what we did. We produced data for 24 African countries, but we received people for training for 54. And that was the first time that Africa come together, to the best of our knowledge, to collaborate in all the big data analysis. So for example, these 2 papers that we published in Science by our team, the first one had 148 African collaborators, and the second one had 324, really creating this very strong network, yeah. And then what we did with a pool of funders, yeah, we launched a very large training program where we received 663 fellows from 50 African countries who spend weeks, months, or years with us, just translating like all this expertise to the rest of the continent. And as the pandemic ended, we had this arm of well-trained people. So we decided together with Luiz Alcântara to join and launch another program that we call CLIMADE, yeah, which means Climate Amplified Disease and Epidemics, that we pivot now to the disease amplified by climate change. And what the best person that we could do that in the world is really with scientists of Brazil, because they are the ones that have the biggest long-term experience dealing, for example, with arbovirus. But what we did is to put a program that go from the disease, genomic data, mobility, climate, human population, vector, with a very strong data science. And I'm going to show you now a very large group of AI scientists. Yeah. Because what was the vision of the CLIMADE? To create a global consortium to generate the knowledge, but also develop the tools and interventions to predict, track, and control disease amplified by the climate change. Yeah, because we really think that that's going to be where most of the large outbreaks will be starting. So, for example, it is estimated that around 60%, yeah, or over half of all the non-pathogens in the world are amplified by climate change. And the way that is estimated, so in this graphic I have in the left what I call the climate hazards, such as warming, precipitation, floods, drought. In the middle I have the way that these pathogens are transmitted, with the bulk of them being transmitted by either vector-borne or waterborne, and on the right, the kind of the pathogen. So the bulk of them is going to be viruses that is transmitted by different vectors or the water, and bacteria. And there you have many of the non-pathogens that now are causing large outbreaks in Brazil, like the dengue, chikungunya, yellow fever, now oropouche, yeah. But then what we decided to do is getting this knowledge and transfer to not only with Brazil, but also to the rest of Africa. So what we did, we had this big program of fellows training all across Africa. And then what we did, if they see any outbreaks, they could either send us the samples or we would send reagents. But then we engage with a program that from the genomes, you could start generate some of the solutions. So I would just highlight some of the outbreaks that we deal and give a quick example. So in Africa last year, it was the biggest global number of dengue outbreaks. So it contributes with a lot to the 14 million cases, which a lot was South America. But in Africa, dengue alone, yeah, we respond to outbreaks, and we did genomic surveillance in Senegal, Burkina Faso, Ivory Coast, Togo, Cameroon, Ethiopia, Mozambique, Reunion, Mauritius, and then with Luiz team in Paraguay, Uruguay, Brazil, and also in our global program with Pakistan, for example. And then as we do the dengue surveillance, other outbreaks happening, yeah, and then we focus a lot on some of the big pathogens amplified by climate change, such as cholera, with the largest outbreaks of the history of Malawi or Cameroon, yeah, or a new emergence of chikungunya in Senegal or Rift Valley in Kenya. So I just saved 2 examples to present to you. The work that we did in Rift Valley fever, and then we're just gonna go to one example of dengue. Yeah. What is Rift Valley fever virus? Yeah. So that's a virus that lives in the environment, yeah, which in normal rains, it lives in what you call interepisodic cycles. So just doesn't transmit and cause outbreaks, yeah. But if you have very heavy rains and flooding, you have an emergence of the vector, in the case mosquitoes, that would fetch that pathogen and first starting infecting livestock, yeah, where the first transmission happened to humans, normally for the interaction between livestock, cows and goats and sheep. But that can enter an amplification cycle that then humans with high viral load would then transmit to mosquito to affect other humans. And this is a virus that have pandemic potential and with a case fatality rate of up to 30%. Yeah. So what we did with Kenya, we work on doing all the genomic classification of that virus, sequencing hundreds of isolates, yeah, and then identifying the main clades that have caused like the large recent outbreaks. So we took that genome, yeah, we engage with, identify a number of potential genomes. We engage then with the mRNA hub with Afrigen, yeah, which then isolate what is the kind of the spike protein of that virus, which it's called the GNGC protein, yeah. So it is a virus that's quite similar to approach in the genomic organization, has 3 segments, yeah, segment S, M, and L, yeah. And then the M segment included the glycoprotein, yeah. So we did the sequence, we use a lot of AI methods to manipulate the sequence to get better antigen presentation, yeah. And then what we did with Afrigen, or what they did, they had a fully functional mRNA vaccine construction that was reverse engineering from Moderna, yeah. And they took out the spike sequence of that, and then they put the GNG sequence of that was manipulated from Rift Valley fever. Yeah, they changed the way that the 5-UTR was expressed just to make sure that you wouldn't do any IP infringement. Yeah, from Moderna. And then you virus transcribe in plummet's DNA and you formulate the mRNA concentration. And then with that, then we took to, and they took to animal models, yeah, they infected a mouse, yeah, which then generated very high levels of anti-GN and IgGs, yeah. And then they selected 3 of these constructs that they have. The constructs have different numbers in the bottom, yeah. And some of these constructs then they took, yeah, from the plasma of the infected mouse. They generate a pseudovirus system. They put that plasma and see if you would neutralize that. And 2 of the constructs, the F2400, 46, 47, and 49, they have stars, yellow stars. They saw some very high neutralization activities, yeah. And then from that constructs they had on the vaccine, they did expression, they created the system using the quantum mRNA system. And then what was very exciting, a couple of a month ago during the World Economic Forum in Geneva, they announced that now that's entering preclinical trial, fully funded by CEPI, with another award of $8 million, with being the first end-to-end vaccine of being identified, sequenced, manipulated, and entering clinical trial in Africa, which is a very big achievement for mRNA. I know that Brazil have done similar achievement, for example, or not with the mRNA technology, but the new live attenuated dengue vaccine from the Butantan. But so it is Africa and South Africa try to catch with that, yeah. So just to highlight another quick case on how a lot of times these epidemics, they are completely associated. So now we go back to dengue, which caused millions of cases in Africa. The largest outbreak of the history of Ethiopia, it happened in the end of 2023, beginning of 2024, in 2 different areas. Yeah, they approach us, we send all the reagents, and we produce the first large number of genomes from Ethiopia. And what we show with these genomes was very surprising. Yeah, the main outbreak strain that was a dengue serotype 3, genotype 3, major lineage B. Yeah, it is with a very clear date of origin and basal to sequence from Italy. Yeah, really suggestion that now Italian outbreak that happened got introduced into Ethiopia and caused the big outbreak of history of Ethiopia. Something that was absolute, that we wouldn't be able to even hypothesize. Always the history is that outbreaks in Latin America or Africa will cause to Europe. So we see that potentially co-circulation. And when we go back to what's happened to Italy, yeah, so not only the genome from Italy was completely basal to the Ethiopia, but also Italy at that year in middle of 2023 had the highest number of cases, yeah, across all the regions. And the epidemic curve showing on the left there on pink also predicted the Ethiopian epidemic curve, really suggesting the potential of now outbreak in Europe fueling a large outbreak in Africa. Then we took all that information quite serious. We use large systems of modeling and artificial intelligence to then map across Africa the disease susceptibility of both dengue and chikungunya. I'm showing for dengue here, with all the flight data around the world. And just to start to calculate the right origin of when you see outbreak in a region of the world, how they will be introduced or not in Africa. And what we found, some very clear signal that in East Africa, with very high importation from Asia, West Africa, from South America, and some of the countries with the highest air flux between regions, such as between Brazil and South Africa, with low transmission potential, just highlighting that it's likely that a lot of introductions from dengue or chikungunya from Brazil would arrive in South Africa or Angola, but with very low epidemic potential there, and they end up dead en route. And what we are doing is just advancing these models to be able to do that in real time and predicted. Yeah. So my last 5 minutes, I just need to highlight some of the work that was very similar done by the CLIMADE program, but under the leadership of Luiz Carlos Alcântara in Brazil and in Latin America. He took the same approach, a very holistic approach that he trained hundreds of scientists, especially across life science and public health institutes across our neighboring countries to respond to large outbreaks. And I'm just going to bring quick 2 examples that's showing. One of them is the very clear association that we found between increasing temperature in Paraguay, yeah, with the explosive of the large outbreak that Paraguay ever had of chikungunya. And Luiz's team, it went to Paraguay, it did that all in real time. In less than 3 weeks from start the outbreak, they have characterized all the genomes, yeah, and the source of spread. And that was a very large outbreak that at that time, in the end of 2023, it was close to 90% of the case fatality in deaths in Latin America. And what they did, it's again, the opposite of what they expected or we expected. Our hypothesis that was a cross introduction from chikungunya from Brazil to Paraguay. But what's happened, it was a similar strain that have caused very few cases in 2022 that may have evolved, yeah, to then with climate change, yeah, and start spreading, enter Asunción, yeah, and then start spreading, especially falling the high density areas and moving from Asunción on the left to the rest. And that was a very important work because they could characterize not only the genomes of all the fatal cases, neurological cases, and the first neonatal cases suggest mother to child transmission. And of course, as new epidemics arrive, we now have these very large data teams between ours to characterize. One of them is help the characterization and spread of oropouch. But just to bring you some very big advances in methodological on the A and B map, when we start putting all the satellite data, together with the climate and genomic data to start to calculate like what's likely to have caused the start of outbreaks. And here was very clear associated with decrease of evergreen broadleaf forest cover, potentially associated with the big drought that we had in Amazon in 2022. Virus moved close to urban areas, and then it's starting evolving to falling human population density, flight data. And that's what CLIMADE is trying to do, is really to use this very advanced data science, satellite models, artificial intelligence to track and start predicting. And then to finish, also with the big project that we have with Luiz, completely led by Luiz de Navio, it is to start going before epidemics arrive, and to start characterize that on the potential new zoonotic transmission. So thank you, it's a great pleasure. We have engaged not only with the scientific bodies, but also with the COP last year. We had we launched the second year of the climate change and epidemics report. The photo there on the top, Luiz again with his nice Navio hat, with the World Health Organization, in the first time that the WHO has a pavilion in the COP. We also did participate and launch the previous version in the COP 28 that was by. And then we are really engaged with the Brazilian to be able to do that again in COP30. So thank you, Luiz. And then we really look forward for any interaction.
Okay, thank you, Tulio. We really appreciate your talk. It's very nice. You have time for questions.
Me? Yeah, I have all the time in the world, and I wish I was there.
Hi, Tulio. This was very interesting. I'm glad to finally see some data of dengue circulation in Africa. And I'm wondering if you have any ideas, because we know the epidemiology of dengue in South America versus Southeast Asia is very different for many reasons, but one of them is the vector. So there's a lot of albopictus-driven transmission in Southeast Asia. And in Africa, there was always the question that the Aedes aegypti formosus, that's more prevalent in Africa, would not be a good vector. So what do we know of the transmission? Do we know which vectors are driving the transmission in Africa?
Yes, thank you. Yeah, thank you very much. Yeah. So what we found in Africa, and I'm just gonna go a few slides back, is that most of the transmissions, it is from Aegypti. That seemed to be associated. And we did characterization of all these different countries, and they tend to concentrate in urban areas, with the presence of Aedes aegypti. But that said, the one that we are currently worried, is the one that we finished the work now at the moment with reunion on the chikungunya and Mauritius, that chikungunya seem to have the strain, now it's being transmitted by albopicus, and it added the A226V mutations, which allow much better transmission by albopicus, And that happened also around 15 years ago on chikungunya, and that strain became to spread very widely in Asia. So you are correct to say that a lot of time this adaptation to albopicus, And that's the one that we are very worried because it's starting the summer in Europe, And also they have very high prevalence of albopicus. And given that Reunion is part of the French area, we are identifying hundreds of introductions of chikungunya using now not a Jeptai but albopicus, and potentially start a global outbreak, not only in Africa, already moved to cause the very large outbreak in Mauritius, but potentially entering Asia and via Europe, potentially entering other areas in the world. Yeah.
Thank you.
Okay. More question? Okay. Because of the time, and I'd like to thank Tulio to be with us today, and I hope to see you in this afternoon in our private meeting. Okay, thank you very much.
And I hope to see you in the end of July in Brasilia to the Climate and Health Conference, and to really thank Luiz and Fiocruz. I work with Fiocruz for over 20 years, yeah, and it is a great collaboration, especially when we can, countries in the Southern Hemisphere, help the world to become a safer place. And I'm very proud about your guys' work. Thank you.
Thank you. And now we will change. For the first table, I will invite Dr. Sônia Ribeiro. She is a professor in the Department of Cartography from University of Minas Gerais, and she has a PhD in Environmental Science from the University of East Anglia in North UK, and actually she coordinated the Center for Remote Sensorial Institute of Geoscience in University of Minas Gerais. Thank you, Sônia.
Thank you very much, Luiz. It's my pleasure to be the chair of this session on climate change and the infectious diseases. I'll be here with you during this morning. We'll have 3 presentations before coffee break. And the 3 presentations will be by Professor Jorge Kalil, with the title "Toward Preparedness for a New Pandemic." Then it follows Dr. Fabiano Pimenta from Ministry of Health, with the title of his presentation is "Strategic Policies of the Health and Environment Surveillance Secretariat." And last but not least will be Adriana Lucena, representative of the Brazilian Ministry of Health, with a presentation on strategic policies of the health and environmental surveillance. I'm very pleased to call to the first talk Professor Jorge Kalil. Professor Jorge Kalil is a full professor of clinical immunology and allergy at the School of Medicine at the University of São Paulo, and is director of these services at Hospital das Clínicas. Is director of the immunology laboratory at INCOR, and adjunct professor at American universities such as George Washington, D.C., and Case Western Reserve, Cleveland. It represents Brazil on Scientific Council of the Institute of Genetic Engineering and Biotechnology by United Nations. Since 2001, is coordinated the Institute of the Research and Immunology, INCT. Is also co-director of the Center of Excellence of FOSSIS, Federation of Societies of Clinical Immunology in São Paulo, and a member of the board of USP Pasteur Institute platform. Is a member of the US Government Data and Safety Management Board for Oversight of COVID-19. Professor Jorge Kalil is also a member of the Brazilian Academy of Sciences. So it's such an honor to receive you here at UFMG at this meeting by CT-Vacinas. Thank you very, very much. The floor is yours.
Thank you, Sonia, for the introduction. Thank you, Ricardo, for inviting me to come. I'm not going to do my punctual research in the development of vaccines, but rather I would like to talk to you today about the threats. Well, Tulio talked already about the threats that we are living of a new pandemic. And I changed the title to prevent a new pandemic, but rather to preview the new pandemics, because we know that something is coming. Already in 2015, people are aware that pandemics could come, and I don't know if you remember, but there was the H5 threat of influenza that was running in China. And at that time, I was directing Butantan, and we produced the master cell bank for producing very quickly a vaccine against H5. So the idea was always that a respiratory disease would be the big threat for epidemics. But we know that here in Latin America, also in Africa, as Tulio was showing, we have many threats also that comes from mosquito-borne diseases. And I will try to address the issue how we are seeing the problem in Brazil, but how the WHO is also working in this particular field. So the talk is what the world is doing to prevent the pandemics and what are priorities for Brazil. Of course, this is very controversial. That's what I want to be. So when we think on vaccination, there's that very interesting paper published last year on Lancet on the contribution of vaccination to improved survival and health. I talked a little bit about this yesterday, modeling 50 years of expanded program on immunization. As I remind you yesterday, in 1983, the WHO asked for all the countries to organize immunization programs. And we created at that time the National Program of Immunization that has been very, very active. It's one of the big assets we have in Brazilian health. And I just pointed this first phrase here. Since 1974, vaccination has averted 154 million deaths, including 146 million among children younger than 5 years of age, and 101 million were infants younger than 1 year old. And that's why I think that we have much better numbers of people that are surviving the first year of lives here in Brazil, but also in Africa. Actually, around the world in Southeast Asia. So vaccination is so important, and people have to understand this. And it's not only a problem of nutrition. That was the explanation why there is this measles burden in Texas. So what is the scenario? So we are talking about dengue. Dengue is a big problem. And it spread. I mean, this year was terrible again. These are the numbers of 2024. The probable number of cases were over 6 million cases only in Brazil. The deaths clearly related to dengue were about 5,000. Under investigation, 2,000. And this is underestimated, of course, because we don't know the real numbers. But why do we still have it? We could control the mosquitoes. We do have vaccines. The Sanofi vaccine didn't work well, but then we started a program when I took the office at Butantan Institute in 2012 there was a program on a vaccine that was being developed at NIH. So actually at NIH, they have done the attenuated virus that we know that work very well for this arbovirus. And it was sitting in the freezers of Butantan as well. There were the same attenuated virus were sent to India and to Vietnam. Nobody did anything. Was it a product? No. For us scientists, it was a product. At that time, when I took over Butantan, the science was to have the attenuated virus. But people that have been involved in development and production knows that this is only the first part, and there's a lot of work to do. So the Steve Whitehead and Anna Durbin, Steve Whitehead from NIH, Anna Durbin from Hopkins, they have tried to develop the program as much as they can, but they didn't have dengue in the United States. So, but they could do the production on GMP conditions of the virus, and they have tested the virus, the attenuated virus, in monkeys and humans. And it worked as a phase 1. But the problem was how to produce large amounts of the virus, how to stabilize the virus, how to purify the virus, and how to make the virus possible to become a real product. And that's what we did at Butantan. So there is a partnership between Butantan and Laboratory of Infectious Disease at NIH. There was a transfer of the attenuated virus to Butantan. And in Butantan, we did the industrial development. So two lines here, but years and years of work. How we do a virus production, yields, and purification, how we stabilize the virus and lyophilize the virus in good conditions. And then we had the clinical development and the phase 2 clinical trial. We could convince the Brazilian FDA and Anvisa that the work that was done at NIH would be considered a phase 1. So we went directly at that time to a phase 2. And this phase 2 was done in my medical service at the Hospital das Clínicas at the School of Medicine, University of São Paulo. So I was in both sides, so it was easy for me to bring this study to the School of Medicine. And at that time, we compared the frozen samples of the attenuated virus that came from NIH and the actual product that we developed at Butantan. That means produced in high quantities, stabilized, lyophilized, and so on and so forth. And at that time, the seroconversion rates were very high for dengue 1 and 2, but they are very good also for dengue 3 and 4. So you can see here that the dengue vaccine from Butantan gave a trivalent response to 95% of people. And when you take the trivalent, so this tetravalent response, over 75%. So it seems to be a good product. It was perhaps the best product that we had. And we went on and asked Anvisa for a phase 3 clinical trial. So we are talking 2014, end of 2014. But Anvisa did not respond very quickly. I was very critical of, I criticized a lot Anvisa at that time. Nowadays, I know that they evolved a lot and they are doing a great job, and they did a very great job during COVID-19. But at that time, it was too political. And although I asked to have this phase 3 clinical trial at the end of 2014, and I could have started immunizing people in 2015, that there was a big outbreak in Brazil, this vaccine would have been approved in 2015-16. But that's not what happened. And it took me 1 year to get it approved because they wanted to do a big event that we are starting a phase 3 clinical trial. So what we have done, we have created 17 centers of clinical trial in Brazil. Here, there is one that is very active here, Elton who participated, that was created here. And the idea was, I talked to people that were my friends in the different states of Brazil where dengue was present, that were good researchers, academic research, so it was not very expensive to do the trials. And I asked them, what is missing? What do you need? Some would need a nurse, some would need a bioinformatician, some a pharmaceutical, some would need a building. That's what happened here. I have to rent a building for the center here. And these 17 centers were ready to go. It took me the time, so we trained everybody, distributed, produced the vaccine. It's just for you to have an idea how is to produce a vaccine in Brazil. And finally, we got the permission. But to get the permission, we had to do a political event. See? So the political event, you may not recognize me here. This was the volunteer, but you certainly recognize our president at the time, and our governor at the time, vice president today. Everybody wants to be in the room of vaccination because everybody wants to be in the pictures and the television. And then was this ceremony at the Hospital das Clínicas. And this ceremony was, of course, our president talking, the governor, the Mayor of São Paulo, that now is our Minister of Economy. It was the Minister of Health. The Minister of Defense was there. And I don't know if you can see from behind here how happy I am in this. Well, anyway, we launched the program. This is February 2016. Till now, we don't have it. Why you don't have it? Because the person that came after me didn't pay attention. Merck came to see me and said, you have a better vaccine than we have. They first proposed to use their vaccine as a booster for our vaccine, but we did not need a booster. This is a one-shot vaccine. It's like yellow fever vaccine. So we are doing a very big deal. We are going to transfer technology from Butantan to Merck. What do you think? For Brazilians, what a proud. It never happened as it should have happened. And we would earn a lot of money for Butantan to develop new vaccines, including SpinTech. But so this was the start. And at that time, 2016 was the beginning of the Zika problem. And I have to tell you the story. Ricardo, you cut me. I don't need to go to the end, but I'd love to tell these stories. One day I was on a Saturday night in my beach house. I tell you, you can cut me. I was in my beach house after drinking 2 or 3 whiskeys. I received a call from the Minister of Health. And he said, well, our president received a call from Obama telling her that she should not be worried about the Zika program because the president of BARD at that time, that was cut already, Alan, in the first Trump government, came to Brazil to see me, and we launched the program on the Zika vaccine. And things were going very well. Of course, he called me. I explained to him exactly what we were doing, and my wife said he didn't understand a word what we said. So write to him. I said, but after 3 whiskeys, okay. I wrote him, and we started the program. And here, Dilma said, in order to start the program on the Zika, I will give you the equivalent at that time of $3 million to start the program Butantan. I was happy. I didn't have any money for the Zika. When we were going out, the lawyer of the Minister of Health said, don't count on this money. It will never come to you. And it never came. Well, anyway, after many years, this should have been done. We had to look for dengue 3, dengue 4 in other places, but we had only outbreaks of dengue 1 and dengue 2. This is the result of the vaccine compared to the placebo. That was pretty good. I'm not going to go too much in detail. So it works pretty well in protecting against dengue, but only 1 and 2. And we are asking for the approval of the vaccine. I'm just afraid of dengue 3 because we had the worst results with dengue 3. And dengue 3 is coming into Brazil, as you know. We have now dengue 3 present in the country. So let's see what's going to happen. But as we have said before, we had the problem of Zika. Zika came, Zika disappeared. Do you know why? If you know why, tell me. We don't know. Because we were expecting Zika in São Paulo, 2017, didn't show up, and it's hidden somewhere. It could come. Do we have a vaccine? No. We don't have a vaccine yet because that program didn't go ahead. We have the problem of chikungunya in Brazil. It's a big problem. Teófilo was talking about chikungunya. There is a vaccine that was developed by Valneva from Europe that apparently has been tech transferred to Butantan, but for the time being, Butantan is not producing it. So we cannot count on the amount of vaccines that would come to Brazil because everybody would like to have a chikungunya vaccine. It all depends on pricing and so on. For the time being, Butantan is not producing, although apparently there is a tech transfer of this vaccine. This would be also a very important vaccine. So we talked about 3 arbovirus, dengue kills, Zika causes the problem with fetus, as you know, and chikungunya has many rheumatic problems. So these are problems that we have to solve. And we have those respiratory viruses running around. This is data that they collected from the Institute for All for Health in a free translation of this institute that I created, and I was president for a couple of years, and then I decided to return to my lab. Elder was one of my consultants. I saw him entering there. And we could, by using only data from private laboratories, we could follow the epidemics of different respiratory virus in the country. Why we decided to work with these private laboratories? Because the results came much quicker than true governmental data. But see, everything is, all these respiratory diseases are there, and we have always the problem of the influenza. Because influenza, it's very important right now, influenza A in Brazil. We have many, many cases, and we always are afraid of H5 coming. So that's why we started, when COVID started, we started the development of a nasal instillation vaccine. So we do need instillation vaccines that work in order to actually control respiratory diseases. And respiratory diseases, virus diseases, are the ones that actually cause pandemics. because although I have shown arbovirosis, we always try to control mosquitoes. By the way, I have to tell another story. When I went to talk to the São Paulo authorities that I was working on a dengue vaccine, they said, why are you losing your time? We have killed all the mosquitoes. That's the way the politicians think. So we decided to work on nasal instillation vaccine because we need to protect mucosal and systemic immune response. This mimics natural infection, large absorption surface, vascularized, and non-invasive. And we have been working, and we have been collaborating with CT-Vacinas for this. And after testing more than 52 different formulations, we got to a vaccine where we have a RBD plus peptides that are adsorbed for a nanoparticle, and this is covered by a mucoadhesive nanoparticle that can cross the cilia, the mucosal fluid, and attach to mucosal cells and actually develop IgA, secretory IgA. That's the real important thing in order to have protection in, as you can see, saliva and nasal lavage. We don't want that much IgA in the bronchoalveolar lavage. We want that the virus is stopped in the upper respiratory system, and in this case, we can control infection. And that's what we actually happened. We did challenge experiments of 3 intranasal doses, and we could protect the animals for being killed. We induced pseudovirus neutralization antibodies that in the serum, so not only nasal, but also protect serum. And we have shown that this was the most important, that once we have the oropharyngeal SARS-CoV-2 in animals that were or not immunized, we can see the drop of the numbers of viruses. See, this is logarithmic scale. See, it's at least 5 times less in 3 days, and we don't find the virus anymore after 5 days. So this is a way, if you can develop this platform and could be used by other respiratory viruses to control respiratory diseases. If you can induce, even if you have to induce every year, a good immune response, we do need a good mucosal vaccines. And when I started this, everybody was laughing and saying, are you going to use Afrin? Do you know what's Afrin, the vasoconstrictor? And I said, no, that's the way to go. And then last year, I think, Alan, I don't think I'm correct, United States realized that they really had to invest in this vaccine. My time is over? I didn't start other viral threats in Latin America. So are this virus here, but also hundreds of viruses that have been isolated by the Vander Chagas in Belém. And with the climate change, they can go out of the jungle and cause disease. Sometimes we've seen São Paulo patients that come with fever and die of disease, of virus that we don't know. So very, very quickly then, we have the national vaccination program that I talked to you yesterday. But we need immunization across the life course. This is the problems related to respiratory, syncytial respiratory virus. I don't have the time to go through this. Just want to tell you a few words about preparing for the next pandemic threat, and what about pathogens prioritization. So in 2017, before the pandemics, WHO created a group called RD, Research and Development, RD, Blueprint, that met regularly to discuss what would be the threats that the world would have for a pandemic. See, so there was no news actually when we got this pandemic. Everybody was expecting it. And then we met last year, exactly one year ago, in Geneva. We were 50 people that we analyzed the study of 350 researchers that studied all the families of virus and some families of bacteria that could bring to a pandemic. So the idea would be to find what would be the prototype pathogen for a particular family of pathogens, and then what would be the priority pathogen that would be, would have more chances of transforming that pathogen from the family in a pandemics. And we propose R&D in order to be ready for pathogen X from that family to become a pandemics. This was a wonderful work, and we had a very good time in Geneva working on this. So I mentioned to you the priority family, the priority pathogens, the prototype pathogen. I'm not going to go in detail. My time is over. But we came with some numbers of families and some pathogens that would be important for preparedness of new pandemics. So we have the potential, of course, of the zoonotic influenza. It's here, it's out there. We have also a new coronavirus coming. I had many comments. I don't have the time, I know, but I think I mentioned the most important. So we have to study the protective immune response for the different infectious threats that I mentioned to you. We have to know how to produce vaccine with the appropriate platform. RNA vaccines are not the only solution. Everybody thinks that everything will be RNA. I don't think so. Of course, all my talk is with my bias, I know. How to do constant surveillance of infectious threats in Latin America. We have this beautiful work that Luiz is doing with Teófilo, but we have also others like the Institute All for Health that are doing similar work. And vaccines against parasites are very difficult, as you know. Vaccines against bacteria are not easy, and vaccines against virus can be developed. Now, if a human is protected after developing a disease caused by the virus, it's possible to produce a vaccine. If the vaccine covers the most common serotypes of recurrent virus, we can do it, but it's very difficult to fight against nature. If the immune system cannot eliminate an infectious agent, it's very difficult to do a vaccine. And this Rolf Zinkernagel, or Nobel Prize for immunology, always gave this talk. Pay attention when you try to develop a vaccine. Okay, I finished. I'm not going to go to all my comments. I just want to thank you for the opportunity. And we have to think about, in order not to be surprised by a new pandemic coming. And I want to remind you that North is different from global South. So we have to have things related to global South. We have to emphasize this research on the pathogens can be a threat for global South. Thank you very much.
Thank you very much. It was a very nice talk. Particularly, we can have questions this time because Dr. Fabiano Pimenta will not join us, unfortunately. He has... But, okay, let's go for a short round of questions.
Well, at the end, you mentioned, I think, something that's very important, that's the South, global South, be prepared. And one thing that worries me is the compositions of the influenza vaccine, that I would think that till today we use all the information from the North and not from the South. I think we have the capacity we have the big groups doing the influenza type, and why we don't change that? Or maybe I'm wrong there, it has been changed, but I don't know.
No, next time I come to Minister of Health to fight for this, I'll bring you. So when I was directing Butantan, you have 4 months to prepare 60 million doses of influenza vaccine in eggs. So every day, 500,000 embryonated eggs arrive in Butantan. Did you know that? Can you imagine that? So the amount of eggs that arrive. So we have to prepare very quickly. And what Director in Butantan I did, I prospected what were the important viruses around the world, and I would guess 1 or 2, and I would start preparing the virus before it actually had the choice of the virus that should compose the vaccine. This is done on September 28th every year, and by the end of March, the vaccine has to be ready to be distributed in Brazil. And in 1 year, I was wrong. So I thought in one H1N1, I can't remember, I think it was California, that was giving a lot of problems. I don't know if you remember, 2014, 15, there were a lot of influenza in Brazil. And I have chosen California. And the WHO chose Missouri strain of H1N1. And of course that I lost all I have prepared. But I was not convinced, because the studies done by Fiocruz and others that were doing the surveillance in Brazil showed me that California was the important one. But WHO thinks that way. There is a seasonal influenza in the north, seasonal influenza in the south. They may be different. So they study the north. It's a pity we don't have a map of the world, but you will see that the north is connected, right? We have one country after the other. The only biggest distance would be between London and New York, 7-hour flight. But in the north, Groenlandia and Russia, they are connected. So the north, it's understandable. But the south, they collect data from Brazil and Australia. I can tell it, I just came from Australia. It's not easy to transmit a virus from Australia to Brazil. And at that year, they have chosen Missouri because it was pretty important in Australia. And they did, and they put little weight in the results we had in Brazil that California strain was important. And I must say that was a terrible year of influenza in Brazil, because we had the wrong strain of influenza. So we have to think that the transmission in the north is horizontal, while the transmission in the south is vertical. So we got the virus from United States, Caribbean region that reaches South America. And Australia gets the virus, I don't know from where, because they are isolated from everybody, but probably from Japan, China, and other countries in the east. So I think there is a problem. And at that time, I remember Jarbas was the secretary for sanitary vigilance, I think. I don't know if it's the correct word in English, but, and I talked to him a lot. And he agreed with me, but he said, this WHO that imposes us this vaccine. So this is something to be discussed with the Brazilian government that should be independent, but also with WHO.
Thank you very much. Thank you very much. Let's now introduce our next speaker, Adriana Lucena, a representative of the CESAI, Brazilian Ministry of Health, and the title of her presentation will be Strategic Policies of Health and Environmental Surveillance. Adriana is full technologist in the general coordination of the National Immunization Program of the Ministry of Health, and she is currently the coordinator of indigenous health surveillance at CESAI of the Ministry of Health. The CESAI is responsible for coordinating and executing the national policy for healthcare for indigenous peoples and the entire management process of the indigenous healthcare subsystem in the unified health system. Welcome, Adriana.
Bom dia a todos e a todas. Bom, eu quero agradecer ao UFMG e ao Luiz, do CLIMADE, pelo convite. Eu estou representando aqui a nossa diretora do Departamento de Atenção Primária à Saúde Indígena, que é a Putira Sacoema, que infelizmente não pôde vir, por outras urgências e agendas da Secretaria de Saúde Indígena. E eu quero, antes de iniciar aqui a apresentação, eu peço desculpas, porque tivemos, nessa última semana, vários imprevistos e eu não consegui traduzir, infelizmente, a apresentação para o inglês, então peço desculpa aos profissionais, aos participantes que não entendem bem o português, e eu não me atrevo a falar em inglês aqui, mas vou tentar falar pausadamente para que possam compreender. Eu sou a Adriana Lucena, e eu sou coordenadora de Vigilância em Saúde Indígena da Secretaria de Saúde Indígena. Ela é uma secretaria que está dentro do organograma do Ministério da Saúde e que é responsável pela atenção primária das populações indígenas que vivem em territórios indígenas no Brasil. E aí a gente sempre destaca nossa atuação dentro da saúde pública, porque, assim, nesses últimos 2 anos, 2023 para cá, a Secretaria de Saúde Indígena veio apresentando uma maior visibilidade da importância do papel dessa secretaria dentro da saúde pública para os territórios indígenas e da importância da população indígena, de prestar uma assistência de qualidade para essa população. Então, a gente sempre destaca esse papel. Existe um Ministério dos Povos Indígenas, que é diferente do Ministério da Saúde, com a Secretaria de Saúde Indígena. Então, a gente sempre aproveita esses momentos para trazer um pouco sobre isso. E, na temática que veio para a gente, que é relacionada às mudanças climáticas, doenças infecciosas e as estratégias da saúde indígena, isso tem tudo a ver porque nossos territórios foram fortemente, desde 2023, quando a gente está acompanhando, foram atingidos por essas questões climáticas. Então, nós somos a secretaria que coordena o subsistema de atenção à saúde indígena dentro do SUS. Temos uma política própria para essas populações indígenas. A gente leva toda a atenção primária e de vigilância para esses territórios. Então, só para vocês conhecerem um pouco do que é a amplitude da saúde indígena, nós temos 34 distritos sanitários especiais indígenas, distribuídos em todo o país. Os territórios indígenas, nós temos mais de 811 mil populações indígenas que vivem em territórios que são dessas populações indígenas, mais de 7 mil aldeias, mais de 346 etnias e mais de 274 línguas. Nós temos diversidades culturais e temos populações indígenas que não falam português, falam suas próprias línguas, e alguns, desculpa, está mais seco aqui, mas alguns eles falam português e a sua própria língua nativa. Então, nós temos uma amplitude de atuação que precisamos levar a atenção primária e vigilância como para os não indígenas, mas precisamos introduzir nos nossos profissionais e nas nossas ações a questão cultural, e de origem das medicinas tradicionais. Então, só mostrando, a gente tem as unidades básicas de saúde, os polos bases e as casas de apoio para essas populações. e especificamente sobre as mudanças climáticas. Como eu coloquei, nos eventos extremos, as nossas populações foram fortemente atingidas. Entre os anos de 2023 e 2024, nossos territórios, de norte a sul, sofreram com inundações, enxurradas, alagamentos, chuvas intensas, ondas de calor, ondas de frio, seca e estiagem. Dos 34 distritos sanitários, nesses 2 últimos anos, 22 registraram ocorrências de seca e estiagem que levaram a danos a essa população, seja de isolamento, falta de acesso de água e até mesmo adoecimento. Então, como estratégia, né, que é um dos pontos que é para a nossa apresentação, quais as estratégias que temos desenvolvido para enfrentar essa questão das mudanças climáticas e do risco de adoecimento. A Secretaria de Saúde Indígena criou um comitê próprio de resposta a eventos extremos da saúde indígena, que é o CREESE, que, em outubro de 2023, considerando essas grandes demandas de eventos extremos, para auxiliar na efetivação das diretrizes e procedimentos, para que a gente pudesse ter uma ação coordenada dentro da saúde indígena, também com os parceiros, né, com as instituições de municípios, estados e diversos entes federais. Então, esse comitê foi importante para ter essa formalização e essa constituição de uma atividade única que, antes, a gente, quando essas emergências estavam surgindo, as nossas equipes ficavam meio segregadas e não tinha tanto um direcionamento de como atuar, né, de como atuar junto aos estados e municípios. Então, esse comitê deu essa fortaleza para as nossas ações conjuntas. Então, na Constituição, em 2023, foram definidos documentos orientadores de fluxos de papéis, matriz de risco. Para cada evento que se tenha avaliação de risco, então, depender do nível de preparação ou de mitigação, são realizadas reuniões e todos os distritos sanitários que estão afetados por aquele evento, eles precisam preencher essa matriz de risco, identificando como é que está a situação da população. São elaborados planos de contingência, que aí vem eixo de assistência, de insumos, logística, vigilância e acesso à água, com a matriz de responsabilidade, onde cada ente, não só da SESAI, mas municípios, estados e diversos ministérios do nível federal também são incluídos para identificar suas responsabilidades para apoiar essa população. Então, teve uma definição de um fluxo único de comunicação das aldeias, né? Algumas aldeias você tem um acesso, eles têm um acesso mais próximo às cidades, outros, como na região norte, eles são de áreas longínquas, então eles precisam de radiofonia ou precisam passar horas, né, nos rios para poder ter esse contato, mas foi definido o fluxo que, diante de um evento climático, de um evento extremo, ter esse contato com o polo base, com o comitê estadual, né, com os distritos e com o nível central da gente da Secretaria de Saúde Indígena. Um importante instrumento criado pelo CREESE, que esse comitê, foi o REDCap formulário, porque todos sabemos, né, quem tem mais contato com o sistema de informação, que as notificações, informações, elas são muito demoradas. Então, com esse formulário aqui, de monitoramento dos impactos da seca e estiagem, nós conseguimos ter as informações durante esses eventos mais rapidamente. Então, os nossos profissionais digitavam as informações, se as aldeias tiveram ausência de comunicação, impossibilidade de acesso, dificuldade de acesso à água, a alimento, se teve um aumento no acúmulo de resíduos sólidos, ocorrência de queimadas de fumaça, e também, né, para a questão da saúde, se eles estavam identificando o aumento de doenças nas comunidades. E aí, com esse comitê, o que a gente conseguia mais rapidamente com esse formulário? Por exemplo, aqui nesse primeiro gráfico, nós temos esse aqui é um mapa da Amazônia Legal e mapeado os nossos distritos sanitários. E aqui a gente tem as aldeias foram impactadas. Esse verde mais escuro indica que 80% a 100% das aldeias tiveram impacto durante a seca em 2023. Nesse segundo aqui, a gente tem a seca e estiagem em 2024, também na Amazônia Legal, mas aqui a gente tem aqui percentual de população indígena impactada. E esse vermelho mais escuro indica que 80% a 100% dessas populações foram impactadas. Aqui, ele demonstra para a gente a seca e a estiagem, né, se eles tiveram ou não a falta de acesso de água, em laranja indicando que sim, boa parte dessas populações tiveram, e, a partir dessas informações, ações, né, junto com a Defesa Civil, né, com o Ministério do Desenvolvimento Social, com a Força Nacional do SUS, a gente conseguiu levar assistência e água, abastecimento de água para essa população. Então, aqui, ó, demonstrando, então, nós tivemos rapidamente informações da ocorrência de doenças respiratórias, doenças diarreicas, desidratação, malária, acidentes ofídicos. Aqui, demonstrando, só mapeando também, tivemos, além de seca, inundações, né, no Acre. Então, nós tivemos o extremo agora no Acre, início de 2024, com doenças diarreicas e infecções respiratórias agudas, em outro distrito, que é o Alto Rio Purus. E, no interior sul, também tivemos enchentes. Então, para vocês identificarem que, na saúde indígena, nós tivemos secas e enchentes, né, que atingiram as nossas populações. E, aí, com consequência disso, nós tivemos surto de dengue, né, arbovirose, em 2024, principalmente no interior sul, que eu vou trazer aqui para vocês. Áreas que não tínhamos dengue começaram a passar a existir. Então, identificando que as mudanças climáticas vêm afetando fortemente as populações indígenas. Malária também é o nosso grande problema. Nós temos Yanomami ainda com o maior percentual de ocorrência de malária no território, e ele é fortemente atingido pelas mudanças climáticas, além da questão da garimpagem. Né? E, como ações estratégicas, nós desenvolvemos, nesses últimos 2 anos, a construção de fluxo único de comunicação. A CESAI fortaleceu-se bastante nesse processo, junto às outras instituições. Fazemos parte do Sistema Federal de Respostas. Né? Conseguimos levar provimentos, soluções de abastecimento para essas populações, para acesso à água, né, potável. Estruturação das nossas vigilâncias e parcerias articuladas com as demais secretarias do Ministério da Saúde. Com relação às arboviroses, nós criamos plataformas e painéis que antes nós não tínhamos, e conseguimos ter esse panorama dessas doenças, como dengue, chikungunya e zika, nas populações indígenas. Né? Nós fazemos parte dessa sala de situação de dengue, que foram constituídas em alguns estados e no nível nacional. E, com relação à malária, nós estamos avançando, né, com diversas estratégias. Houve ampliação, sim, da ocorrência de casos, mas nós estamos conseguindo diagnosticar e tratar que essa é a base da malária, né, e algumas ações, como a incorporação da tefenoquina, da testagem de 16PD, para a questão da malária vivax, que é o principal problema, né, da malária nos nossos territórios indígenas. E, por fim, acho que uma das ações mais importantes além das demais, é essa questão da descentralização de soro antiveneno. Então, ao aumento, a gente vem identificando o aumento de acidentes ofídicos, e a gente tem, com a Secretaria de Vigilância em Saúde Indígena, um projeto de descentralização dos soros. Nós estamos falando de comunidades que ficam a dias de distância de qualquer ponto de apoio. Então, nós conseguimos, com a SVSA, fazer ampliação, descentralização de soro para 2 polos base, né, de cada um dos distritos do Amazonas, os 2 distritos de Roraima e os 2 distritos do Acre. E a perspectiva é que a gente consiga reestruturar a rede de frio dos distritos para que a gente possa descentralizar os soros antivenenos para toda a Amazônia legal. Então, basicamente, era esse um pouco da nossa atuação diante das mudanças climáticas e do adoecimento na saúde indígena. Obrigada.
Muito obrigada, Adriane. Teremos tempo para uma questão rápida. Se alguém... Não, eu vou fazer. Claro. De todas essas estratégias que vocês vêm implementando, tem alguma que vocês já testaram a efetividade delas? De tudo que vocês vêm fazendo, qual seria as estratégias que vocês consideram mais eficientes?
Esse processo desse comitê, né, como eu coloquei, ele permitiu que a gente realmente conseguisse identificar rapidamente, porque a junção dos departamentos de outras secretarias faz com que os distritos eles nos avisem rapidamente. Então, a gente fica monitorando com o Instituto Nacional de Meteorologia, né, como é que está a questão de seca e estiagem. Nesse alerta, a gente já aciona os distritos. E aí essa ação sincronizada que está permitindo a gente identificar e acionar os parceiros. A gente, nessas questões com o CRES, a gente conseguiu ampliar recursos extras, mais de 70 milhões, para poder atuar junto com essa população. Né? E da malária a gente tem avançando a tafenoquina, que ela está substituindo em algumas situações a primaquina, ela reduz o tempo de tratamento, né, do paciente com malária vivax. Então, isso está ajudando a nossa população indígena, a conseguir concluir seu tratamento para malária. Então, são essas ações que a gente destaca.
Muito obrigada.
Tá, obrigada.
Thank you very much. Now it's time for coffee break. I'm pleased that we reach on time. We have 20 minutes. We'll be back at 10:55 for the Luiz Alcântara talk. Thank you very much. See you.